sampai closing settle terus dengan okay, itulah katanya.
Dia kan itu yang tadi track tu tanya kan sendiri dulu kan. Yang nanti tetangga tu ada kan dulu seremoni lah kan.
Seremoni
Apa closing dulu lah kan.
closing dulu.
Okay.
Dia capture sound dia tu.
Tak, kalau aku on kan mic ni dia, sebab dia ada mic tu kan dia bergema.
So ini dia capture sound.
Capture sound terus dia direct. Dia
ada mic
lah. Dia mic lah. Kalau betul pun boleh mic juga. Tapi dia dah temu-temu.
Dia double lah nanti.
Tengok tadi berapa persen. Nak cakap lah tengok mati.
Ni kena off lah.
Ni kena off lah ni. Dia boleh kalau nak ni satu pakai yang mic clip tu. Macam semalam kan. Tapi kena anu kat PA system tu. Takut lah cocok kat situ lah. Tapi ni tengok ni tadi test demo je.
Okey lah.
Ini dah masuk ni.
Russian and English language.
Okay, hi everyone. Good afternoon. I would like to say something before we close the session. Actually, the session is still on, but it's like a closing remark. Yeah, because I'm afraid if I wait until the end, many people go away. Okay. Good afternoon, everyone, especially our distinguished guests, professors, research scientists, students of the world. I'm very grateful, I'm very thankful to you all for coming into this 11th i-CEPEC 2024, in which at the beginning we feel that, wow, we are going to get involved in this conference before, and then they asked us actually to organize this conference. But alhamdulillah, by the grace and mercy of God, everything going fine. Okay. So I would like to take this opportunity to thank you all, especially our local community members who worked so hard to make this happen, to invite everyone coming, organize, make everything running well. And I would like to thank everyone who come from different part of the world. And I would like to thank especially to Professor Dong, who become the initiator or maybe the founder for this conference, who entrusted us to organize this 11th i-CEPEC conference. And I would like to take the opportunity to thank everyone also to enjoy yourself and coming to Kuala Lumpur you can visit many places over here. And I believe you have been here many times, but this time maybe we have this conference, and then you can also take the time to visit the city and country. Okay, I would like to invite Professor Dong. Maybe you want to talk some before we end. So, Professor Dong.
Thank you, organizer of this 11th conference. So, congratulate, very successful conference. You have worked very hard, and so especially in this southeastern country area. So you invited very distinguished experts and professors, researchers, also industry people. So all together we have discussed a lot of concerns in this climate change era. So I would like to appreciate all the participants for sharing time with us. So we had some international advisory committee meeting yesterday. So and we discussed for the next conference and some venue, country, and some next our conference time also. So we have decided to host again i-CEPEC conference in Korea. So naturally, we are turning our conference Korea, China, Japan, and Thailand, Malaysia. So again, back to Korea. So let me introduce briefly in our past conferences. So we have 24 years history. So we have a lot of issues concerned with energy and whatever energy sources and converting energy. We have some air pollution problems. So nowadays we have some big issues concerned with the climate change, right? So all of these topics can be dealt with in this conference. So we will share our research results and whatever development experience in each country. So we can help together or communicate for to promote our international cooperation. First, i-CEPEC was held in South Korea in year 2000. So there are some participating countries. So almost 100 participants initially, and the people number was 65 here. So on your right-hand side, you can have some proceedings and some facts. So some attendants are still keeping that small bags. Second one was held in the Jeju Island, Korea also. You can see some countries and participants and papers were here. So i-CEPEC conference was held in Hangzhou, China, the Zhang University. So on your right side, some proceedings here, and then some beautiful bags. Also, there was a real expanded version of i-CEPEC. So many experts from Europe and the United States also started to join this conference. So you can see some experts from US, Canada, UK, and France, and Sweden. The first one was held in Kyoto University, Kyoto, Japan, in 2006. So our ISP conference is held biannual years. We are also here are some proceedings here and next possibly Superior City. So it's maybe Kinkakuchi maybe. But fifth one was held in Chiang Mai, Thailand. It's very beautiful city. So we had a very good experience. Our expanding of our conference to Southeastern Asian countries together. So you can see many countries started to join this conference. So participants almost 150, and the paper number around 67. Okay, sixth one was held in Kuala Lumpur in 2010. So a lot of experts participated, and then here's some proceedings and some backpacks for some leave. Okay, seventh was again in Korea, Kintex Ilsan. So a lot of the different countries, joined here together. So almost 500 participants, attended with the paper number 235. So it's expanded a lot. So namely the international, conference. Eighth one was held in Zhejiang Hotel. It's a very beautiful West Lake in Hangzhou City. Maybe you can imagine, how big the West Lake is, right? So it's very beautiful, and the number of participants grew to 2,000, almost 50. So here is a picture of some participants. So many experts around the world attended this meeting. The paper number is 185. Again in Japan, in 2016, it's the Kyoto Research Park, Kyoto, Japan. So very beautiful city in the time. So we enjoyed staying there, and we shared the friendship. And hence was held in Bangkok, Thailand. So we gathered again in Southeastern Asian countries, and we enjoyed our cruise dinner time, and we got some famous singers and dancers there on board. So it was a very beautiful night. So almost 300 participants and 145 papers. So I'm not sure about the result of this conference, but still very successful. So, but unfortunately, we had some long time because of COVID-19. So there is some 6 years gap from previous conference. But we successfully reopened our conference here in Kuala Lumpur. So again, is going to Korea for the 12th i-CEPEC conference. Okay. So we discussed about the time of conference. So we share the time to October 15th, October 15th to 17th. Place it is just so is considered, but there is some other suggestions like Jeju Island, Busan, and Gyeongju. So when I return to Korea, we're going to discuss again the place, maybe. But there is some other beautiful cities around Korea. But yeah, you can think about some other city rather than Seoul. Busan is, I think, another alternative. And Gyeongju is the capital city of old ancient Silla dynasty. So it's good for staying there with some sightseeing places. So I'm going to notify again for the exact place. So please remember the time of 12th i-CEPEC, so October 15 to 17. The time is not fixed. So I will share some time again in Korea. And again, I thank you very much for your participation in this 11th conference in this beautiful city of Kuala Lumpur. Thank you very much.
Thank you, Professor Tom. With that remark, I would like again to thank you all for coming to this conference. I will thank to my team who worked hard to make sure this conference successful. And I wish you, and let's remember, it's not the beginning. Okay, after COVID, it's the beginning of your continued relationship. And I wish you all will be again joining the next i-CEPEC conference in Korea. Okay, hope to see you all there, and hope to have a safe trip. Okay, you can continue relationship with each other. Okay, thank you very much. Sit down.
Sit down.
Okay, smile everyone.
The better
Hold the chair. Hold the chair. Okay, smile. Okay.
Okay, 1, 2, 3. Okay, smile. 1, 2, 3. Start. Okay, please start. 1, 2, 3. Video.
Okay.
Bye. Bye.
Bye. See you in Korea.
Okay. All right. Thank you.
Nggak apa-apa.
Thank you.
Thank you, sir. Thank you.
Well,
You stay. If you can share some information about you, share what's your
너무 화려해 보였습니다.
Maybe after my PhD I could consider coming to Korea to find a job.
right?
I could come to Korea for a postdoctorate.
You had the receive what semester? Here,
Okay, no, this is my second semester.
second semester. The finish second semester.
No, I have about 6 semesters.
Or total. And
Total 6, and I have done more.
two.
Yes, I'm here now. I still have 1, 2, 3, 4 semesters. Complete my application. I still have a lot of time to consider so many opportunities. Somewhere along the line, I want to finish up. I'll go to Nigeria, work for some people and then come back again, get some other opportunities.
Global.
Opportunities. Then I could still, there are some other proposals actually to the Nigerian government. So we can partner. We can form partnership. There's some proposals presented to my state government. Then they will fund the project that we can do together to get some contracts from the government. So there are so many opportunities. There are many opportunities.
Wherever you stay, keep in touch.
Yeah, we want to keep in touch. I have your number.
My friend Frederick.
Yes, Frederick.
Yeah. Okay, thank you.
Take care of yourself.
Yeah. Kusanagi? Is there Kusanagi? 신민철. Yes. 아직. 네. 임호섭?
제가 대신 발표합니다. 제 학생입니다.
누르살와 서영삼?
금방 있었어요.
모하마드 바시? 누르살와 죽은 있는데 제목은 다르네요.
제목이 다르서 같이 하시죠.
누르살하고 보는데 쿠스나기? Is there 쿠스나기?
없으면
패스할까요?
아니요.
교수님, 첫 번째 발표자는 저기 그 사장님이신가요?
아, 그래요?
예, 그 키노트 위에 써 있는.
죄송합니다.
예.
성함이 원장님.
아니요.
장조.
네, 장조.
죄송합니다. Yeah. First type keynote speaker Jang Ju-oh. Yeah, we will have the keynote speaker type. Please. Wait a moment. 그 저기 자료가 혹시
한글로 써 있는.
이거야.
그걸 넘어가라.
오케이. 네, 맞습니다.
Okay, good afternoon, everyone. My name is Chu Chang. I'm a PhD candidate of Hoso University Graduate School, Energy, Climate, Environment, Conversion Technology, long name. So, today I will presenting my research titled The Impact of Hydrogen on Energy Security, focusing on power generation. This study analyzes the role of hydrogen energy in addressing energy security challenges, particularly through the well-established 4A's framework. Next. As the world transitions to cleaner energy systems, hydrogen is gaining increasing attention as a potential solution to meet climate goals and energy transitions. Its versatility, abundance, and zero carbon nature make it a promising energy source. South Korea's energy import dependence remains high, driving the need for secure and domestic alternatives. This study explores how hydrogen, especially for power generation, can reduce this dependence and align with carbon neutrality targets. So I have two questions to guide this research. How will hydrogen as a power generation fuel impact energy dependency? What are the broader implications for energy security? To analyze hydrogen's role in energy security using the 4A's framework: availability, accessibility, affordability, and acceptability. Traditional meaning of energy security by the Daniel Egin is that energy security has traditionally been defined as ensuring affordable, adequate, and stable energy supplies without jeopardizing national goals. This concept of energy security focuses on supply stability. However, historical oil show. Sorry. So I already explained about the framework of 4 A's: availability and accessibility, affordability and acceptability. But about the 4 A's framework of energy security evaluation, is critics such as Chow and Jessica Jewell and argue that the 4 A's fail to address key questions like security for whom and what value, and emphasize vulnerability as a key factor. Despite limitations, the 4 A's framework effectively balances the multi-dimensional aspect of energy security. So I started using the 4 A's to evaluate high hydrogen's role in security. So I conducted semi-structured interviews based on predefined questions about. I conducted semi-structured interviews based on predefined questions about the structured interview, and interviews were transcribed. Text processing removed the stop was using the OCAT Python library. Topic modeling using LDA identified tools like Phi LDABs and keyword extraction helped interpret. LNG projected to drop from the 35%, 6% and 23 to 0 by fuel power generation. It's just not planning, exactly planning, but the scenario. Nuclear power will provide stability, but its share will decrease slightly, 23.9, like this. The renewable energy will dominate at 70.8%, and is hydrogen and ammonia will be get a portion percentage to get goal of carbon net zero. This slide, I will present the result of topic modeling analysis they conducted using LDA. The key output shown here includes like this. Just I show the one example. It's a total overall participants view get data. So coherence score and analysis, topic similarity. So let us start with the graph on the left side, which displays the coherence score for different number of topics. The coherence is measure of how interpretable and meaningful the topics are. So as you can see, the coherence score peaks when the number of the topic 3. 이게 안 되네. 아니 넘기는 게 아니라 보이지가 포인트. So the peak of the number 3 is topic 3, indicates the optimal number of topics. For the interview data is 3, as it provides the best balance between interpretability and granularity. On the right side, as you have the topic similarity diagram, which visually represents the relationship, the 3 identified topics, which circle represents one of the 3 topics. The connecting lines show the level of similarity between the topics with the numerical values indicating the strength of relationship. Here, so we observe the 3 topics are relatively distinct, but they share a moderate similarity with value of 0.65 between each pair. So the number means is the more closer to the 1 is a little bit different. More closer to 0 is very similarity we have. On this slide, I will present 2 visual outputs from the LDA topic modeling analysis. On the left is the inter-topic distance map, which shows how topics are distributed and related. On the right is the bar chart displaying the top 30 most relevant terms for one of the topics. Let's begin with the visualization on the left. This is inter-topic distance map created using multi-dimensional scaling. The circles represent the identified topics and their positioning reflects the degrees of similarity or overlap between them. Here we observe that topic 1, red, is relatively distinct, are closer to each other, indicating that topics share some similar terms and closer concepts. The size of circles represented the prevalence of each topic in the interview data. For example, topic 1 is the largest, meaning it accounts for the largest portion of the text. On the right hand side, we see the top topic was for which accounts for 43.8% of the token in the data. The red bar represents the relevance of terms specifically for topic 1. The blue bar indicates the overall term frequency across all topics. By analyzing this chart, we can identify the key terms associated with topic 1. Notable terms include, like maybe very small letters you cannot see easily, but first word among the 30 words is number 1 is hydrogen, energy, and power generation. Other relevant terms like renewable and storage suggest a strong focus on hydrogen as a clean energy source for power generation and its role in achieving energy security. The topics derived by LDA topics modeling are shown in the table like this. Which topic consists of 10 key keywords and the keywords coefficient, which reflects the weight of each keyword in that topic. Therefore, the words at the front of each column are keywords that play a key role in the topic and embody the topic of topic. On the other hand, the number of topic does not indicate its importance in the document. In other words, a lower topic number does not indicate that topic is more important or has a higher frequency. For example, topic 1 does not mean that it is important than topic 3. Just like this, among the top 10 keywords, researcher should be interpreted what that word's meaning for energy security based on the getting my data from the my participant interview. The result of analysis based on the 4S framework, from the point of view availability, hydrogen is abundant and versatile with the potential for domestic production through green and blue hydrogen. However, scalability remains a challenge to the high production cost. In the view of accessibility, expanding infrastructure like hydrogen refueling station and global collaborations improves accessibility though safety concerns persist. In the sense of affordability, hydrogen costs are significantly higher than fossil fuels. Government subsidies and R&D investments are essential for reducing costs. Lastly, about acceptability, public support aligns with carbon neutrality goals, but safety perceptions require awareness campaigns. Based on the findings, I propose the following policy measures. Ensure robust policy to support renewable energy and hydrogen development. Providing long-term government incentives and subsidies. Encourage public-private partnership for commercialization and infrastructure. Implement safety regulations for hydrogen handling and transportation. Diversify energy resources, draw international cooperation to establish stable global hydrogen supply chain. To conclude, hydrogen energy is a domestic and versatile resource, strengthen energy security while supporting carbon neutrality. Its role in diversification and environmental acceptability is crucial, but economic challenges and technological constraints remain. Establishing a global hydrogen supply chain and leveraging nuclear power as a transitional backup will be critical for ensuring long-term energy security in Korea. Thank you very much for your attention.
Thank you. I'm very impressed you performed the topic modeling, whether it's good. Yeah. Topic modeling is a very useful vehicle to analyze unstructured data. So we waste management industry use this methodology more than now. Yeah. Do you have any question? I have one question.
Yes.
Yeah, hydrogen is very good energy source, but as you mentioned, hydrogen have some challenge due to high production cost. What do you think? Is it realistic? And this is the right direction for our society?
Thank you very much for your question. And actually, it's my personal opinion about the hydrogen. You should go there as to get environmental issue. But among my interview from the very experienced experts, I think so we have some kinds of hurdle to get there. So it's the cost impact and the technology level also. But eventually, we will get to go there for Korea's economic continuous growth, is my opinion.
Yeah,
So,
thank you.
yeah.
Now, CAPCO, they have some project regarding hydrogen power.
Yes, of course. And then CAPCO is my
Hydrogen power.
yes, of course. And then CAPCO is my company and the service organization for focusing on the hydrogen project and just study. And also we have a research center in CAPCO technological resource, and they strongly focus on the hydrogen at the moment.
Okay,
Yeah.
thank you, sir.
Okay.
Okay,
Thank you.
great.
Thank you.
Yeah, thank you. Thank you very much. Is there Kusnati? No. Okay, I see. From continuous pyrolysis of CNS. Great. Yeah, please.
Good afternoon. My name is Min Shin. I working at Songgwang ENF in South Korea. I conducted related pyrolysis research about 2 years, and I have tried pyrolysis various feedstock, waste plastic, and solid molding fuel RDF, and biomass using by continuous equipment. The topic of this presentation is sustainable fuel production from continuous pyrolysis of cashew shell cake and empty fruit punch. The content of this presentation is as follows: introduction, continuous pyrolysis equipment, feedstock, pyrolysis results, product analysis, and conclusion. Songgwang ENF is spin-off venture company from KEIMM. We specialize in R&D-based product manufacturing using patent technology, and we aim to provide total solution for both pollution and energy. Our business area covers various fields related to pollution and waste treatment. In this presentation, I will focus on biomass waste pyrolysis and carbonization. Pilot continue for each section, right? Drying zone, melting zone, pyrolysis zone, and carbonization zone. And here are our reactor tests and advantage of our reactor's design. First, wrapped oversight, feedstock input, and air with a large internal surface area compared to battery and kiln type of the same volume. Here are actual operation data. Continuous pyrolysis equipment. Products are categorized into 3 types: gas and liquid and char. Conveyor is CNSC need residual material left after extraction bunch. It can need first palm fruit bunch, residual material left after palm fruit, fruit from palm fruit bunch removing, remaining empty fruit bunch also need additionally external cooling process like this. The pilot results are as shown. The required temperature, pyrolysis temperature are 450 degrees Celsius for CNSC and 400 degrees Celsius for EFD. Also, the yield of char liquid gas generation, different feedstocks appear similar, but there are differences in max temperature and degree of formation. Let's see this graph. We can check increase and decrease weight data according to the temperature. Blue line is feedstock and orange line is liquid and gray line is gas. We can check CNS is almost no weight change below 300 degrees Celsius, unlike EFB. And biomass characteristic reveal significantly moisture generation during pyrolysis reaction. This non-condenser from generation from pyrolysis. This graph is yield percentage of non-condensable gas at different temperature. We can see green line is CO2, and so gray line is CO. So CO and CO2 are the main components of non-condensable gas. The yield of gas usable, this is usable gas. Usable heat source is approximately under 7%. So in case EFB, generation of fuel gas under 300 degrees Celsius, under degrees Celsius. In case CNSC, showing opposite trend. These are uncondensable, non-condensable gas yield and non-condensable gas calorific value calculation data. We can see CO2 is main component in biomass pyrolysis non-condensable gas, and its total calorific value. So uncondensable gas generated from continuous pyrolysis is not suitable as a heat source because these have a very low calorific value. Moving on, bio oils data. This photo and CNSC oil has you can get approximately 9.2%, and EFB can get 60.2%. The oil calorific value range 8,000 to 10,000 calories per gram, and this under graph is contained GCMS data. Left CNSC oil contain mainly phenol and oleamide. Right EFB oil contain mainly ethylbenzene, acetic acid, phenol, oleamide. So ethylbenzene, oleamide, and phenol can be utilized as stock through further application and chemical treatment. This biochar and this tab contain calorific value, porosimetry analysis, and elemental analysis. Let's compare this biochar and coal. High caloric value and lower moisture contents mean improving heat source efficiency, and lower volatile metal means solo combustion and improving stability and sustainability. And high contain H mean increased readiness to be disposed of after combustion. And high fixed carbon mean improved energy release sustainability. Overall, performance of biochar is generally better than coal. This biochar caloric value calculation data. We can get biochar's yield and this biochar value. When input feedstock 1 gram, we can get this calorie from biochar. And last is when we perform pyrolysis, this calories of feedstock through continuous increment according to a calorific value calculation not suitable as a heat source. Oil rate of CNSC can get 9% and EFB can get 6% obtained during pyrolysis. The main component of pyrolysis oil can be used as sap. In case char, the caloric value of the generated char is approximately 7 to 8 calories per gram, which is higher than that of coal. A yield of about 25 to 30% can be obtained during pyrolysis. It can be used. Thank you. When this machine is our self-producing pyrolysis machine, this we can get electric energy data we can get from this heater using you can get watt data energy.
This is very small scale experimental practice. So maybe can you doing some scale up test? Maybe you should establish some best balance, energy balance, because this is very difficult to get the exact energy, special energy balance. And first, maybe you should set up a best balance. So you're gonna estimate the gas production from the total mass, and maybe first you have some char and oil, but it's very hard to measure gas, right? Gas production is not easy. So maybe you should consider that. Otherwise, it's very hard to split.
The scale is very hard.
Thank you.
Yes, I have a question. Thank you so much for your presentation. My question is about biochar's calorific value. You mentioned biocalorific value higher than the coal. Yes. What does it mean? I mean, actually, as a fuel of biochar is economical than the coal.
I don't know correctly, but biochar can use fuel. Sorry.
Yes, I think my question point is, my experience. Biochar is a different field compared to coal. Coal is mainly to generate electricity as a fuel. However, biochar is different field, I think, used. So you mentioned about calorific value is higher than coal. It's okay. However, to promote biochar is you should research that point also. It's totally different, but biochar is more point to like this. not only cannot be failed, but also something is good point compared to others. Right.
Thank you. I consider that point. Thank you. Okay. Yeah. Thank you for your presentation. Yeah, good.
Thank you.
Post-op, yeah, please come. Yeah. One step pyrolysis and activation for biochar production.
First of all, thank you very much, Chairman. I'm not Hosop Im, I'm Yongwon Song. And Hosop Im is my student, and he's quite busy, so that's why I came here instead. Yeah, that's right. So, so my title is One Step Pyrolysis and Activation for Biochar Production using chili pepper stem and rice straw. And as many audience rice straw, and as many audience will know, we need to make some biochar in many ways, but there is typical way is to pyrolyze it, the biomass first, and then activate it in a later step. So it was kind of two steps, but in this research we applied one step pyrolysis and activations using K203. So myself, I was research topic is research and rice. So the rice is the best portion in here, and also. So this is the annual production of major agricultural byproducts in Korea. It was the data of last year actually, and the first one is rice straw, and the second one is chili pepper stem. Chili pepper stem is we like chili pepper very much. So I think that's because we also produce many of 0.1 million tons for the rice straw and 1 million tons for chili pepper stem. So maybe everyone knows the biochar. The biochar can also is a very good material from the biomass, and it can be used as a soil adjuvantant and also converted into high value added material. In this morning, some presenter talked about it can be used as a supercapacitor also. So also it can be used some kind of absorbent. So that's why we want to make the biochar from this biomass. So usually it is made by two-step activation. The first one is pyrolysis, and the second one is activations. In here, we use the one-step activation. It is chili pepper stem investigated, and the activation was performed with pyrolysis using K2CO3. So this is the basic characteristics of raw materials. The first one is chili pepper stem, the second one is rice straw. You can see here it shows the very typical properties of biomass, and the carbon, hydrogen, nitrogen, oxygen. The oxygen contents is very high. As like the other biomasses. But how we process it was not that easy actually. The chili pepper stem, the raw material is like this, and after drying, we cut it and grinding. So the sample is about 300 micrometers to 2 millimeters. It's this size. But the rice straw is quite easy. You just cut and then drying and then grinding. And after it, we can obtain these kind of samples. So, this is actually the TZ and DTZ graph of chili pepper and rice straw. You can see here, after 500 Celsius, there is no gradual reductions after this temperature. So we set the temperature as 600, 700, and 800 Celsius. And this is the fixed bed pyrolyzer. So this is kind of horizontal electrical tube, and the sample is located in the furnace, and then the into gas, the inert gas is flowing through this way, and then the tar trap is shown in here, and this is wet gas meters to obtain the gas flow rate, and the NDIR is used for the analyze the gas composition such as hydrogen, carbon monoxide, carbon dioxide, and methane. So to compare the two-step pyrolysis and one-step pyrolysis and activation, we also use the pyrolysis sample under the 700 Celsius. Okay? And the product analysis, after the pyrolysis, we can obtain the char and oils and also the gas. The gas yield is it's not easy to actually measure directly. So it is calculated by subtracting the char and oil from the total. Okay. So actually there is some kind of problems in here, but it shows the char, and this lead means the oils, and this is the char. So this is the gas. So what we want to obtain is actually the char, biochar. So you can see here when we pyrolysis and activation, the char a little bit decreases. And when we compared with the pyrolysis, just pyrolysis and one-step pyrolysis and activation, the char yield goes down. So this is kind of a disadvantages when we apply the one-step pyrolysis and activation, but this is because we apply the SCSS and activation steps, and although the char yield decreases, we can also obtain a little bit more of the oils, and so I will show you later the data of the oil later. Okay, so this is, I think, the most important outcome that we have obtained from the one-step pyrolysis and activation. When we compared with just the pyrolysis, you can see here just the pyrolysis, the specific surface area is about just tens in scale, like 16 or 14. So it is quite low surface area. Then when we apply the one-step reaction, you can see a one-step pyrolysis and activation. With the increasing temperature, it shows more than 1,000 cubic meters per square meters per grams. So it shows very high and this is for the rice straw, and it shows very similar trend. You can see here. That's because when we this is the conclusion that when we one-step increases at high temperature, and it is grams, and the two examples shows different behavior in oil analysis, and the panel converted into oxygenate and carbons, which is good for making some oil, the value of oils. And this study was conducted with a low cost and low energy version of existing activation process, and will lead to the research on low cost process, focusing on differences in result and depending on the samples. Okay. Thank you for your attention.
Thank you, sir, Professor. Yeah, it's very good research. Yeah. Do you have some question? Your research finding is very meaningful and especially low cost. Yeah. How did you find it?
Okay. So actually, usually the pyrolysis and activation is done by two steps. The first step is pyrolyzed in a pyrolyzer first, and then we cool down the sample, and then activate it with high temperature using K2CO3 and so on, other some kind of additives. And we think about the low cost and some kind of innovative process, and then my students and I thought there is some kind of research about some mixing together and just to this kind of one-step pyrolysis and activations. So we think that the disadvantage of this process is that you can see here a little bit of reduction in the char yield. So which is not good, which is we need to overcome these advantages. But however, in the terms of energy cost and cost down, I think it is a little bit of a meaningful process.
Yeah, great.
Yeah.
Thank you.
Yeah, thank you.
Thank you. Dulu Sarwa? No? Dulu Sarwa? 영선서? 김병환? Muhammad Bashir? No? No. Muhammad Bashir, no? So only last speaker. Yeah. Our last speaker, Dr. Kim. Yeah. He will speak about mineral carbonation for CO2 capture. Please.
Assalamualaikum. Good afternoon.
I'm Byung-won Kim from Jail Engineering in Korea. My presentation is mineral carbonations of the carbon dioxide capture using stealth slags. My presentation includes the field study of the 5 tons of carbon dioxide per day and its field test results. This year, 2024, is the hottest ever. Climate change is a very serious problem, and Frederick Otto said, we experience the climate changes that brings wildfire and tropical storms. So it means that stronger actions than ever are required. My presentation includes the carbon dioxide capture and used it for the construction materials, especially use steel slags. Steel slag is a byproduct of the steel making process. It's a very famous figure. The carbon dioxide is estimated about 62 gigatons per till 2050. So we should mitigate this carbon dioxide. CCU and CCS its reduction contribution is about 20%. So the CCU is very important technology for mitigate carbon dioxide. It's a schematic representation of the CCU and the CCS. Once the carbon dioxide captured and it treated to store it underground or used many industrial materials. My presentation focused on the mineral carbonation using steel slags. It's the concept of the mineral carbonations. Once the carbon dioxide captured CCS and it is transferred to the construction materials and the chemical materials by mineral carbonation. In this process, there are some construction byproducts and industrial byproducts such as steel slag and the petrol ashes are used. The final product of the carbonation is very stable materials, so it can be used for the construction materials and chemical materials. It's the aqueous carbonation reaction, very simple 3 steps. The first is the carbon dioxide dissolutions in water, and the second step is leaching step, occurring also element into the solutions, and the final step is the carbonation step. It's the formation of the mineral carbonate, such as calcium carbonate or magnesium carbonate. During this process, carbon dioxide is captured by these reactions. We can use many industrial residue materials for the carbon dioxide capture. There are many residues for the carbon fly ash, cement, and MSW bituminous and post-process slag and steel slags. Steel slag contains many calcium cation ions, so it's about 200 and 300 gram per kilograms are included in the steel slags. It's very good reagent for the mineral carbonations. It's the overview of our field study test. 5 tons of carbon dioxide per day. Its location is Sangam Incinerations in Korea. It's a Sangam incinerator, and it's the location of our field study pilot plant. This capacity is about 1,800 standard cubic meters per hour, and main facilities are composed of slag supply equipment, and reactor tank, and the exhaust gas equipment, and the collected material, treatment equipment, etc. It's the overview of our plant. It composed of main 4 reactors. The gases flow sequentially these 4 reactors. Once the slag is mixed with the water and make the reagent slag and water mixing tank first, and is introduced in the reactor 1, 2, 3, 4, and the gas is countercurrent contact with this reagent. Introduce the flue gas is reactor DCBA. During this process, the carbon dioxide content is decreased, and calcium cation ion is enriched in DCBA. Our plant is the steel slag mixing facilities, and it's the main four reactors. And it's the dehydrator and the dryer of the calcium carbonate. We can see this figure. Is the slag silo, and 3 is the main 4 reactors, and it's the dehydrator, and it's the calcium carbonate materials. It's the test result of the field study. As we compose the 4 reactors, as the reactor goes, the removal efficiency of the reactor is increased. In the first reactor, is the removal efficiency about 32%. And the second reactor is 56, and the third reactor 84, and the final fourth reactor removal efficiency is 95. Because it's for the economic benefit, we choose the 3-stage reactor process. It's the continuous measurement of carbon dioxide and of the third reactor. This is the removal efficiency is decreased as the carbon CaO cation is used, and we feed the slag reagent here, and the removal efficiency is higher again, and decrease. Repeat it automatically. It's the XRD of the raw materials and the product of the our process. Raw material composed of mainly calcium hydroxide, about 50%, and the product is calcium carbonation is 85%. We can see the calcium hydroxide change to the calcium carbonation. We come to a conclusion finally. The main mineral carbonation plant achieved high carbon dioxide sequestration efficiency, and the processing efficiency of the capture carbon dioxide by forming stable calcium carbonate. Using this process can provide environmental benefits by recycling steel slag and reducing greenhouse gases. But further research is needed to evaluate the long-term environmental impact and the economic feasibility. Thank you for your attention.
Thank you. CCUS is a really important technique to respond to climate change. Yeah, it's a mineral carbonate. Your technique is really interesting. Yeah. Do you have some question?
It's very promising technology in the future, but we should think about some applicability, right? So, what do you think the main obstacles to make the scale up facilities in terms of technology and in terms of economy?
Yes, thank you for your good question. The main obstacle is the obtaining the high content calcium steel slags. It's very important. And the second thing is it consumes many electricity in the beginning. So we need to optimize this process, and I think the scale is very small. So consumes more electricity, but as the scale is higher and higher, we can make a good economy process, I think. Thank you.
Now 성광 ENF with the energy environmental research lab of your maybe a similar research. Yeah. Right?
Of course, there are many CCU research projects in Korea. All processes cannot be perfect. Each process have some benefit and some disadvantage. So we needed to try to make the good process for the make a CCU in Korea. Thank you. Thank you very much.
We finish. We finish.